Welcome to vectors. We're going to look at some of the operations we can do with vectors, specifically adding, subtracting, multiplying. So there's a pattern when we're adding or we're subtracting. We're going to start with 2a, adding. And that pattern looks like this. V plus W, vector V plus vector W, would be equal to the vector where the two that look like X values get added together. And then separately, the two that look like they're in the place of Y values gets added together. Let's do that now with this particular vector, these particular vectors. I'm going to use -2. I have to remember not to use parentheses. It's breaking a habit. This case is a good habit most of the time. So I'm going to have this vector of -2, 1, and another vector W, which will be 5, -7. Okay. So here's how this gets calculated. So V plus W is the vector -2 plus 5, 1 plus -7, which is simply equal to 5 take away 7 is, well, 5 take away 2 is 3, and 1 minus 7 is a -6. There we have added them together. So that's the vector V plus W. We're going to do the same type of thing, subtracting them. All right, subtract first. So in this case, the way that we would do it, the minus W would be, and I don't really need the equal sign because it's V. Well, I guess it is since they're not in parentheses. I'll put it to be safe. It's going to be simply minus the type of thing. Oops, B minus B, B minus D. So let's use the same two vectors, -2, 1, and W is 5, -7. So what we'll do is the vector V minus W is -2 minus 5 and 1 minus the -7, which is equal to -7. Oops, I want the little thing first. I'll keep it going here is the vector -7. And then this becomes a plus. So it's 7 plus 1, so it's -7, 8. Like, oh, hold on. Let's make that, wasn't that, it was the 8, and then I wanted a better arrow there at the end. Now I got my better arrow. So a very different answer now from adding or to subtracting. So part 2 is add or subtract, and that's just a matter of adding the first values and the second values. Now let's look at what part 3 would be. And this is called scalar, or what it is, I should say. It's called scalar multiplication. There we are. Scalar, in this sense, is sort of like having a monomial, just multiplying one thing, like distributive power. So I'm going to take the number, say, 7a, when a is the vector 6, -5. So what we do with 7a is we do 7 times that vector. So think of it as 7 and then 6, -5, even though we don't write it that way. Instead, what we would do is that 7a is equal to a vector where it's 7 times 6, and then 7 times the -5. So sort of like distributing it. Now, the actual answer, 7 times 6 is 42, and 7 times -5 is a -35. And there we have 7 times a, times the vector a. And that's all it is, just multiply it. If it had been a -7, we would have had -42 and +35, just ended up changing the signs there. If it was like 1/2, well, 1/2 times 6 is 3, and 1/2 times -5 would be -2.5, or -5/2. So you can work with it in different ways. That's scalar multiplication. Now let's look at multiplying not a single number, but rather, I think I got enough room here to do one of these or two of these. I'm going to do it on a different page. I think we'll fit this in right here. This is called dot products. Multiplying dot product. Multiplying two vectors. What seems weird here many times is that you get a single number as an answer. You don't get a vector as an answer with dot products. All the others notice you get an answer that is a dot product. So there's a certain pattern. Let me do it this way. If V is the vector, well, V is the vector JK, and W is the vector LM. Oh, my arrows. Then dW is equal to J times L plus K times M. So the J and the L become this J and L multiplied. The K and the M become K and M multiplied. Let's do that here. So I'm going to put some numbers in here. In fact, what I'm going to do is I'm going to say A is -2, 9. B is 7, -5. So if I want to do AB, I'm going to do -2 times 7 plus 9 times -5. That's -14. That's -45. I started saying 35, which means we get an answer of -59. So AB equals -59. And I guess actually we want the dot product, we just want the number. So I'll say that with it, but then I'll go like this and say B. So following that pattern, you can get the dot product. I'm going to give you one to practice here. All right. Find the dot product of 4, -11 and -9, -7. Go ahead and turn off the video and do this and then come back to it and you'll see what you do. Go ahead and do that now. Okay, welcome back. So CD is going to be equal to the two that look like they're in the place for x values, 4 times -9 plus then the two numbers that are in the back that look like they'd be in the y places. Negative 11 times negative 7. So what we do get here is negative 36, because it's one negative. And then because these negatives cancel out, these two negatives make a plus, we get a plus 77. And that equals the number 41. So CD is a positive 41. That's how you do the dot product. So this one's different than the other things we did before, like adding, subtracting, and scalar multiplying, because you get a single number as a result for the dot product when you multiply two vectors together. Hopefully this made sense and that you're able to do it now too. So I'm glad that you were here, and thank you for watching and listening.